Welcome back, children. Now we have to learn the next topic, that is relations. So let us consider one example. Let A is equal to set 1, 2, 3. B is equal to another set 4, 5, 6. In the last section we have studied how to find the Cartesian product or cross product. So what is A cross B? A cross B means it is a set of all ordered pairs of elements from A and B. First element from A, second element from B. So 1, 4 ordered pair, 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6. Then 3, 4, 3, 5, 3, 6. So there are how many elements? 3 elements in A, 3 elements in B means number of elements in A cross B is equal to 3 into 3, 9 elements. Then in this section we have to learn what is a relation. So relation, a relation R, the notation is R, capital R. This is not set of real numbers. In this particular section we use this capital R as relation. So a relation R from a non-empty set A to a non-empty set B. A and B are two non-empty sets. A relation R from a non-empty set A to a non-empty set B means it is a subset of this A cross B. R must be a subset of A cross B, and this subset is derived by describing a relationship between the first element and second element. That is the definition. So look here. First I am writing R1. Okay. From this A cross B, I am choosing some ordered pairs. That is 1, 2, 4 and 3, 6. Is this a relation? It is a subset of this A cross B, isn't it? This one, these two are in A cross B, so it is a subset of this A cross B. Then can you find a relationship between the first element and second element? A common relationship. 2, 4 and 3, 6. 2 plus 2 is 4, but 3 plus 2 is not 6. 2 into 2 is 4, 3 into 2 is 6. So we can find a relation. What is the relation? This is, and this one is in roster form. We can write in set builder form as set of ordered pair x, y such that the second element is twice of the first element, isn't it? The second one is 2 times the first element. Also you have to write this x is in from which set? X belongs to A and y is in B. This much you have to write. This is set builder form. So this R1 is a relation. Why this R1 is a relation? R1 is a subset of A cross B. So we can say that R1 is a relation from A to B. And we can find a relationship between the first and second element. Another example from this A cross B itself. Let R2 is equal to 1, 4, 2, 5 and 3, 6. Is it a relation? What is the relationship between the first element and second element? Do you get the relation? The relation is, we can write as 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6. So y is equal to x plus 3. X is an element of A, y is an element of B. So this one is also a relation from where to where? It is from A to B, not from B to A. This is a relation from A to B since it is a subset of A cross B, and there is a relationship between the x and y elements. Then another one, 2, 4, 3, 5. Is it a relation? Yes, 2, 4, 3, 5. It's a subset of A cross B. What is the relationship? Here 2 plus 2 is 4, 3 plus 2 is 5. So, y is equal to x plus 2, or you can write x is equal to y minus 2. Anyway, you can write. So, here I am writing x is equal to y minus 2, where x is an element of A and y is an element of B. Okay. Now, is this A cross B itself a relation? I am writing R4 as A cross B, the whole set. 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, 5, 3, 6. Is this one a relation? Is this one a relation? The relationship we can write as ordered pair xy such that the difference x minus y or y minus x. What is the difference between the first and second elements? Here it is 3, here 4, 5, 2, 3, 4, 1, 2, 3. So, 1 to 5, maximum difference is 5. So, I can write y minus x, that is less than or equal to 5. Y minus x is 1 is there, 1 for this one, 3, 4 minus 3 is 1, and maximum 6 minus 1 is 5. So, I can write as y minus x is less than or equal to 5, where x belongs to A and y belongs to B. So, what do you understand? A relation. A relation R from a non-empty set A to a non-empty set B is a subset of A cross B. So, A cross B, how many subsets for A cross B? In A cross B there are 9 elements. So, number of subsets is 2 raised to 9. All subsets are relations. So, a relation from A to B is a subset of A cross B, and at the same time the subset is derived by describing a relationship between first element and second element. So, for this particular example, how many relations possible? There are 2 raised to 9, 2 raised to 9 subsets for this A cross B, and that much relations possible. Now, the relations we can represent in 3 ways. One is this roster form. This is known as roster form, and this one is set builder form. You already studied that. Now, the third one is visual representation, that is known as arrow diagram. Arrow diagram method means visual representation. So, this example 1, 2, 3, 4, 5, 6 we can mark. So, like this oval shape you have to draw. Okay, first set A, second set B. Then in A how many elements? All the elements you have to write in this. That is 1, 2, 3. 1, 2, 3. The second set is 4, 5, 6. Okay. Now, if R2, A to B, R2, what is R2? 1, 4, 1 to 4, 2 to 5 and 3 to 6. This is a relation. Which relation? R2, the relation R2. Similarly, I can represent R1. So, R1 means 2 to 4 and 3 to 6. Only 2 arrows are there. Like that, R3 also 2 arrows, and for R4 there are 9 arrows that you have to draw. So, this visual representation, that is known as arrow diagram method. So, relation we can represent in 3 different ways. One is roster form, the other one is set builder form, and the third one is arrow diagram. Then another important thing is relation on A. What is the meaning of this? Some questions like this. Relation R on A is defined as, it's given like that. So, what is the meaning of relation on A? Relation on A means relation from A to A. Relation on A means relation from A to A. That is, that relation is a subset of A cross A. Then we can generalize the number of relations. Number of relations. Okay. If number of elements in A is equal to M, number of elements in B is equal to N, then number of elements in A cross B is equal to Mn, then number of subsets of A cross B is equal to 2 raised to Mn. Okay, all subsets are relations, so we can say that number of relations of A cross B, number of relations from A to B. From A to B is 2 raised to Mn. Okay. Then another important thing is, so we write like this: R1, R2, R3, R4 in roster form. What is the domain and range? What is the domain and range? Domain means set of all first elements. Range means set of all second elements. So what is domain of R1? What is domain of R1? Domain means set of first elements. Which are the first elements? 2 and 3. So domain of R1 is 2, 3. That is not ordered pair set 2, 3. And range means range of R1. R2 is different. Range of R1 is, look at R1, set of second elements. Second elements means 4 and 6. So range of R1 is 4 and 6. Then similarly, what is domain of R2? Domain of R2. What is domain of R2? Set of first elements 1, 2, 3. 1, 2, 3. What is the range? Range of R2. Range of R2 is 4, 5, 6. Okay. And here look, range is same as this B. Here range is not same as B, it is a subset. And domain and range, the other term is codomain. You have to learn these three terms. One is domain, one is range, the other one is codomain. Codomain of R1, codomain of R2, codomain of R3, everything is same. Codomain means the relation from A to B. That second set is known as codomain. So codomain is equal to B. What is B? Set 4, 5, 6. Okay. So we can say that this range, second set is known as codomain. Range means set of second elements. So they are related. Range here in the first case it is a subset of this 4, 5, 6. Second case range and codomain are equal. So we can generally say that range is a subset or equal to codomain. Range cannot be superset of codomain. It is a subset or maybe equal to codomain. This much you understood? So once again, I will explain once again. The second part is relations. What is a relation? If A and B are two non-empty sets, then a relation R from A to B is defined as it is a subset of A cross B, and this subset is derived by describing a relationship between the first and second elements. Okay. Then relation we can represent in three different ways. One is roster form, second one is set builder form, and the third one is visual representation, that is arrow diagram method. In roster form we list all the elements. set builder form, we have to write the properties. We have to write the relationship between x and y elements. And look the arrow diagram. You have to draw like this, two oval shapes. First set, second set. List all the elements. How many elements in A? Everything you have to write in this. And all the elements in B also you have to list in that. Then which all related, that only you have to draw. Okay, using arrows you have to draw. Then the set of first elements. That is known as set of first elements of ordered pairs of the relation, that is known as domain of the relation. The set of second elements of the ordered pairs of the relation, that is known as range. And the second set, the whole set, relation R from A to B means B is known as codomain. If R is from B to A, then A is known as codomain. Then range and codomain, what is the relation? Range is a subset or equal to codomain. Then number of relations. Relations means it is a subset. So number of relations, if number of elements in A m, number of elements in B n, then in cross product there are mn elements. The number of subsets for that cross product is 2 raised to mn. So that much relations are possible from A to B. Okay. Then another word is relation on A. Relation on A means relation from A to A. Okay. Now we can do problems. Look at the first question. Let A is equal to set 1, 2, 3, 4, 5, 6. Define a relation R from A to A. And R is given as set of ordered pair xy such that y is equal to x plus 1. Depict this relation, that means represent this relation using an arrow diagram. Write down the domain, codomain and range of R. R means this is the relation, that particular relation. Satisfy which all ordered pairs, that you have to write. So first we write in roster form. R is a relation from A to A. Okay. So no need of writing A cross A. It is difficult. In A there are 6 elements. So A cross A, in A cross A there are 36 elements. It's difficult to list all the elements. So just look the relation and you write which is required. That's enough. So R means, R is given as ordered pair xy such that y is 1 more than x. So this one is in set builder form. We can write in roster form. After that we can draw arrow diagram. So in roster form, y equal to x plus 1. This x is in where? A. Okay. And y is also in A. So first you put x. These values you have to put for this x. So when x is 1, when x is equal to 1, what is y? When x is 1, 1 plus 1, that is 2. When x is 2, y is 1 more than that, 3. When x is 3, y is 4. When x is 4, y is 5. When x is 5, y is 6. And when x is 7, you can give x as 7, when x as 6. So what is y value? Y is 7. But this 7 is not in A. Okay. This relation is from A to A. X values and y values, all these elements 1 to 6 only. So we can't take y as 7. We can't take y as 7. So you can stop here and write as ordered pair. When x is 1, y is 2. Clear this? How to write? Put x is equal to 1. So y is 2. Then put x is 2, y is 3, 3, 4, 4, 5, 5, 6. Next x we can give 6, but y equal to 7, that is not in that set. So you have to stop here. So this method is known as roster method. Now we have to represent this using an arrow diagram. So for arrow diagram, draw like this. 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. First set, what is the set? A to A itself. Okay. Now mark this. 1 to 2. Draw an arrow. 1 to 2. Now 2 to 3. 3 to 4. 4 to 5. 5 to 6. So 5 pairs are there. So this is known as arrow diagram. Now write down the domain, codomain and range of R. So this is the first part of the question. Now second part I am writing here. What is the domain? Domain of R, range of R and codomain. What is domain? Domain means set of all first elements in R. Look R. Okay, don't take from here. The domain is not 1 to 6, which all have this. This second part is known as, this is, look here, 1, 2. This 2 is known as image. What is it? Image. Usually we use this image in the next section, but the second element is known as image of the first element. So what is the domain? Domain is the set of first elements of this R. First elements 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. For this 6, there is no image. So 6 you don't want to write. Now what is the range? Range is the set of second elements. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay. What is the codomain? Codomain is the second set. Second set is what? Second set is A itself. This relation is from A to A. So either you can write codomain as A. You can write A or this set 1, 2, 3, 4, 5, 6. Okay, or that is same as A. In the next question, this figure shows a relationship between the sets P and Q. Write this relation in roster form, set builder form. What is the domain and range? Okay. So first we can write in roster form. Look at the figure and we can write. So set ordered pair. First element from P, second from Q. It is a relation from P to Q. So first I can write 5. 5 is related to 3. Now 6 is related to 4 and 7 is related to 5. So this is the roster form. Now in set builder form, how we write this? This is R. R itself in set builder form. So we have to write ordered pair xy such that what is the relation between first and second elements? 3 plus 2 is 5, 4 plus 2 is 6, 5 plus 2 is 7. So y is equal to x minus 2 or x is equal to y plus 2. Anyway you can write. Okay. Then this also important, x is an element of P, y is an element of Q. This part also important, that also you have to write. So this is set builder form. Now what we have to write? Domain and range. What is the domain of R? Domain means set of first elements. So 5, 6, 7. It is set Okay, without the set symbol, that is wrong. Domain means it is a set, range is also a set. Domain of R, then range of R. Range means set of second elements. What are the second elements? 3, 4, 5. That is the range. Now the next one. Let A is equal to 1, 2, 3, 4, 6. R be the relation on A defined by set of ordered pair AB such that A and B belongs to A. B is exactly divisible by A. Write R in roster form, find the domain and range. So A is given as 1, 2, 3, 4, 5, 6. 5 is not there, only 1, 2, 3, 4 and 6. R is a relation on A. What do you mean by R is a relation on A? R is a subset of A cross A. Okay. And we are not writing A cross A, it is very difficult. 5 elements, 5 into 5. 25 elements we have to write, it is very difficult. So you read this relation and write only those elements which satisfy this relation. So R is equal to, what is the relation? Ordered pair AB, both elements belongs to this set A, and the B, that is second element, is exactly divisible by the first element. Okay, so in that way you have to write. Children, if you write A cross A, what is A? 1, 2, 3, 4, 6. A cross A means 1, 1, 1, 2, 1, 3, 1, 4, 1, 6. This is the first letter 1. Now the next row 2, 1, 2, 2, like that, 2, 6, like that, 6, 1 up to 6, 6. Those who find it difficult to find this relation, you write in this side what is A cross A. Okay. Now R is the relation AB such that B is exactly divisible by A. So can I write 1, 1? 1, 1 is in this set. 1, 1 means this 1 is divisible by this first one. So 1, 1, like that I can write 2, 2. 2, 2 will be here, 2, 2. Like that, 3, 3, 4, 4, then 6, 6. Then I can write 1, 2 is divisible by 1, 1, 3, 1, 4, 1, 6, 1, 2, 1, 3. Second number is divisible by the first number, 1, 4, 1, 6. Now I can write 2, 4, 4 is divisible by 2, 2, 4 in this second row, 2, 4. Then 2, 6 is possible, 6 is divisible by 2. Then 3, 6, 6 is divisible by 3. Any other elements? Okay. So this is R. Now write R in roster form. That is this first part. Write R in roster form. Second part is find the domain and range. Domain of R and range of R. What is the domain of R? Set of all first elements. First elements means 1, 2, 3, 4, 6. Finish. 1, 2. Now range means set of second elements. Second elements 1, 2, 3, 4, that also. Find the domain and range of R. So here both are equal. Now the next one. A is equal to set 1, 2, 3, 5. B is equal to 4, 6, 9. Define a relation R from A to B by are equal to ordered pair xy. The difference between x and y is odd. X is an element of A, y is an element of B. Write R in roster form. We have to write in roster form. What is the relation? The difference between x and y is odd. So x from the first set, y from the second set. A is set 1, 2, 3, 5. B is equal to set 4, 6, 9. Then R means it is a subset of A cross B. Okay. So A cross B. Those who want, you write A cross B and you select the pairs which satisfies the relation. So it is 1, 4, 1, 6, 1, 9, 2, 4, 2, 6, 2, 9, 3, 4, 3, 6, 3, 9, then 5, 4, 5, 6, 5. So here what is R? R is the relation satisfying the relationship. What is the relationship? The difference between x and y is odd. It is not given y minus x is odd or x minus y. So you don't consider the sign either positive or negative, whatever. Just you find the difference which should be odd. So 1, 4, what is the difference? 4 minus 1 is 3, that is an odd number. So we can write in R 1, 4, 1, 6, difference is odd. 1, 9 is 8, 2, 4 we can't take, 2, 6 we can't take, 2, 9. Then 3, 4, 3, 6, 3, 9 is not possible. 5, 4. 4 minus 5 is minus 1, no problem. Neglect this sign and write it is an odd number. 5, 6, then 5, 9 we can't take. So this is R. R in roster form. Okay. Now the next one, A is equal to set 1, 2, B is equal to set 3, 4. Find the number of relations from A to B. R is a relation from A to B. We have to find number of relations. So number of elements in A is 2. Number of elements in B is 2. What is the number of elements in A cross B? 2 into 2, 4. R is a subset of A cross B. So number of subsets is equal to how many subsets for this A cross B? 2 raised to 4, that is 16 subsets. So what is the number of relations? Number of relations from A to B. A to B is also 2 raised to 4 is equal to 16. And the last one. Let R be the relation on Z. Z means set of integers defined by set of ordered pair AB such that A comma B belongs to Z. That means A and B are integers. A minus B is also an integer. Find the domain and range of R. Domain and range. Domain means set of first elements. Range means set of second elements. And the first element A, where is this A? A is an integer. B, the set of second elements means set of B's. B is also an integer. Okay, this integer set of integers means it is an infinite set, infinitely many integers. So here you can write as domain means set of first elements. That first elements belongs to Z. So Z is the domain. Now range means set of second elements, that is B. B is an integer. So range is also an integer. So range means set of integers that is known as Z, that is denoted as Z. Domain means set of integers denoted as